In talking about trigonometric functions, there's actually some more properties that surface. In mathematics, we call them identities. In another, I guess, another word for identities, I might also use equivalencies, things that are equal. Okay. Um, for instance, when we may have already put this together, but if we know that sine of t is y over 1 and cosecant of t is 1 over y, we talk about those being reciprocals because, right, y over 1 and 1 over y are reciprocals. The numerators and denominators are exchanged. In the same way, we can formalize that by saying that in this instance, that sine of t is equal to 1 over cosecant of t. And also you could write it the other way around. So cosecant of t is equal to 1 over sine of t. I'm not going to write that out for all of these. The others, so cosine of t and secant are reciprocals. So you'd have 1 over secant of t. And our last one would be tangent. So we'd have tangent of t is equal to 1 over cotangent of t. Okay? Reciprocal identities, reciprocal equivalencies. The thing on the left is equivalent, equal in value to the thing on the right. Okay? So if the term identities bothers you, use equivalencies. They are the same value. Okay? Now, the next one, you can see they are going to be the Pythagorean identities. They all come from the base equation of the unit circle, x squared plus y squared equals 1. And you can see on here I say cosine of theta is x, sine of theta is y, so we get the first Pythagorean identity of cosine squared of theta plus sine squared of theta is equal to 1. And just a note here, when I write cosine squared theta, what that really means is you take cosine of theta and square that. It is not the same as cosine of theta squared. Okay, that actually is saying you square the angle when we're trying to square the quantity, square the output. Okay, now in addition, so again, these are called the Pythagorean identities in mathematics. You can talk about them as equivalencies. Whenever you see the thing on the left, right, the cosine squared plus sine squared, you can replace it with 1 because they are the same value. Okay, the other forms of this you can find by dividing this whole equation by cosine or the whole equation by sine, and those forms are, so if you divide by cosine, you would get 1 plus tangent squared of theta is equal to secant squared of theta. Okay, and the last one is, so you would divide both sides of the equation by sine, you'd get cotangent squared of theta plus 1 is equal to cosecant squared of theta. Okay. Truthfully, I only ever remember the cosine squared plus sine squared, and then I say, okay, well, I need to get the other ones. Let's divide by sine or cosine and see what we get. Okay. But again, with each one of these identities, each one of these equivalencies, replace, if you see cosine squared plus sine squared, or 1 plus tangent squared, you can replace it with the quantity on the right hand side. Okay, which might make our life a lot easier. Okay, so far we have the reciprocal identities, equivalencies, Pythagorean identities, Pythagorean equivalencies, and then the last thing that is going to be extremely helpful for us is a little mnemonic. All students take calculus, and I say hope because calculus is fun. It's where math gets really, really interesting. But it tells us information about the sign of trig functions and quadrants. Okay, so we have quadrant 1, 2, 3, and 4, right? So the ASTC stands for all, and then students in quadrant 2 take calculus. Okay, what we use this in practice is that all trig functions are positive here, in quadrant 1, greater than or equal to 0. In quadrant 2, students is sine and cosecant are positive. In quadrant 3, T is for tangent and cotangent, greater than or equal to 0. And then C is for cosine and secant are greater than or equal to 0. Okay, so if you're given some information like, oh, cosine is positive, then that automatically means, well, that's either in quadrant 1 or 4 because that's where cosine is positive. Okay, so let's look at an example where we use that information. So we're given that tangent is that, and sine is less than 0, so find secant. Oh, okay, this is interesting. All right, so I have no idea what theta is, but maybe there's some information that'll help me. So I know that tangent, right, of theta is 100. Well, 100 is positive. Tangent is positive in quadrants 1 and 3, right? Okay. And then I know from this other information, sine is negative. So that occurs when, so if sine is positive in 1 and 2, that means it's negative in 3 and 4. And so I'm thinking that in all, my angle is going to be an angle whose terminal side is in quadrant 3. Okay. So I still need to find secant. How do I find secant? I'm given tangent. Wait, there was a Pythagorean identity, right? That related tangent and secant. Let's use it. So we had secant squared of theta is equal to 1 plus tangent squared of theta. Okay, so this is 1 plus 100 squared. Okay, so 10,001 is secant squared theta. Okay, well, solve, right? Square root both sides. Secant of theta is equal to, and now since I introduced the square root, I needed the plus and minus. 10,001, square root of that. It's a wonky number, it's fun. Okay, so now I just need to decide, is it positive or is it negative? Okay, how do I decide? I decide by looking at the quadrant. Okay, in quadrant 3, secant is negative because cosine is negative, so I need the negative sign. Okay, so my final answer is that secant of theta is equal to negative square root of 10,001. All right, so just to recap, I had a lot of information. Okay, I recognized to find secant, I needed to use the Pythagorean identity, and I could get that, right? I could go pretty far with that, but eventually I would get to the point where I needed to decide between a plus and a minus. Okay, how I figured out between the plus and minus was because of the quadrant that the angle was in. The information given to me was that tangent was positive 100, which occurred in quadrants 1 and 3, and sine was negative, so that was 3 and 4. And so since both conditions were satisfied in quadrant 3, I knew my angle had to be in quadrant 3, which then forces secant to be negative. Okay. So now we have one more exercise, and I want you to try and sketch or try and work through this on your own before you watch the solution. Kind of go through the same process. We're given cosine. We're trying to find all the other ones. Okay. And we know where the terminal side is. Try it out. A Pythagorean identity maybe involving cosine would be a good place to start in addition to a sketch. So I did a little bit of work. I'm not done yet, but I started with the Pythagorean identity equivalency of cosine squared plus sine squared is equal to 1. Okay, and technically, we could have maybe found secant before. We'll worry about that later. But I started with this identity, and I just drew a little sketch of the scenario so I was aware. Okay, substituted in cosine, right? 4 over 11 quantity squared plus sine squared of theta is equal to 1. Okay, I'm trying to find sine theta, so I need to isolate that. Perform the arithmetic, square rooted, and now I'm at the point where I need to decide between a plus and a minus. And in this case, I am going to choose the minus only because I'm in quadrant 4. Okay, and in that quadrant, sine, which is the y value, is negative. So sine should be negative square root of 105 over 11. Okay, with that information and cosine, I can get everything else. Okay, so cosecant would be the reciprocal, negative 11 over square root of 105. Secant is the reciprocal of cosine, 11 over 4. Tangent would be sine, so negative square root of 105 over 11, all over 4 over 11, so sine over cosine. And something like that further be negative square root of 105 over 4. And then cotangent would be the reciprocal of tangent, so negative 4 over square root of 105. Okay, and I will put a little asterisk next to cosecant and cotangent. You could rationalize those if you feel so compelled, but this is fine for now. You would multiply by square root of 105 over square root of 105 and move that through. But that's the idea. So in these sorts of problems, you want to make sure to use a Pythagorean identity to move between one trig function and another one. And then in doing the Pythagorean identity, you will need to decide between a plus and a minus. Make sure that the sign, the plus or the minus, is consistent with the quadrant that you're in. And once you do that, you're pretty much smooth sailing from there. Okay, so that kind of wraps up this video. But remember to make use of ASTC and the Pythagorean identities and the reciprocal identities in your work with trigonometric functions.